Hello everyone, am I audible? Gautam, Assalam, am I audible? We are doing the chapter permutation and combinations. Alright, and we finished permutations. Alright, today we are going to learn about combinations. Alright, combinations. Write it down. Did you guys complete the NCERT permutation? Gautam? Did you complete NCERT of permutations? Shravya, have you completed the NCERT of permutations?
Almost left.
Almost done. Alright. Okay, Gautam. No worries. Take care, alright. Finish it this week. Okay, write down. If we have to choose R things out of n different things, then the number of ways you can do that is NCR. Alright. And you know what NCR is? NCR is n factorial upon n minus r factorial into r factorial. Write it down, then I'll explain. No worries, Asma. We have started combinations. Alright. This is the first thing we are doing today. Alright. We finished permutations. So you finish NCRT permutations also and all the assignments. Okay, write it down. Okay, everybody wrote it down. Ashma, Abdul.
Yes, sir, written down.
All right. Okay. So you know how to solve this NCR, right? We already did that. How to apply this? If you have a question, in how many ways you can choose a team of 11 players out of 16 players. All right. They are asking in how many ways you can choose 11 players out of 16 players, right? And here I told you the definition. If you have to choose R things out of N things, then NCR is the way to go, right? So you have to choose 11 things out of 16 things. So the answer is 16C11. All right. Out of 16 things. So the value of N is 16. You have to choose 11 things. So 16C11. This is 16 factorial upon 16 minus 11 factorial into 11 factorial. All right. You can solve this and find the answer. Is it clear to everyone? Shabya, Gautam, Ashma, Abdul.
Yes, sir.
All right. Very easy. You write it down. Let's try to solve another question. A question paper has two parts, part A and part B. Each containing 10 questions. If a student has to choose 8 from part A and 5 from part B, in how many ways can he choose the question? Alright. A question paper has two parts, part A and part B, each containing 10 questions. If a student has to choose 8 from part A and 5 from part B, in how many ways can he choose the questions? Try to solve this. Alright, I'll give you a few minutes. Anyone solve this question? Shravya, Ashma, Gautam? $297 ways. Okay. Shravya, Ashma, what happened to you? Okay, let's see. See, this is a two-part question, right? This is, let's call this A and B. Here we have 10 questions. Here you have 10 questions. You have to choose 8 from this and 5 from this, right? So 8 questions out of 10. So 10C 8, 10C 8, 5 questions out of 10, 10C. Now the question is, shall we add them or multiply them? What should I do? Shabya, can you answer? Should I add them or multiply?
Add them.
Add them. Why add?
So he can choose how whichever questions he wants.
Okay. See, read the question again. You have to choose 8 from part A and 5 from part B.
Then multiply.
Multiply, right? You have to choose 8 from this and from B. Then the whole question is complete, right? You cannot choose this
Yes, sir.
or this. Yeah. So you need to multiply. So 10C8 into 10C5 will be the answer. Okay, simplify this. This is 10 into 2 factorial into 2, 5, 10, 2, 3, 6, 8. Multiply this. 9 into 9 into 7 into 2. You'll get the answer. Yes, why I chose to multiply. See, Gautam, I told you basic principle of multiplication and addition, fundamental principle of addition and multiplication, right? So I told you whenever you use the word and, right, you have to choose 8 questions from part A and 5 questions from part B, right? So choosing 8 questions from part A is 10C8, choosing 5 questions from part B is 10C5. You have to choose this and this. Then the purpose of the whole question is completed, right? In how many ways you can choose the questions. If the question said 8 from part A or 5 from part B, then you would have used plus, right? Whenever you use or, you add. Whenever you use and, you multiply.
Sir, what is the final answer after solving it?
The final answer is 11,340.
Okay, sir.
Okay, everyone is
Could you
clear?
please repeat
Ashma?
the final answer? Sir, could you please repeat the
11,340.
final? Okay.
11340. Yeah. Abdul Arsalan, is it clear? All right. Next question. In how many ways A committee of 5 members can be selected from 6 men and 5 women, consisting 3 men and 2 women. And this is part 1. Part 2 is 2 men and 3 women. Try to solve this. I'll give you a few minutes.
So what is after 5 women?
5 members can be selected from 6 men and 5 women, consisting 3 men and 2 women, 2 men and 3 women.
Okay, sir.
solve this. Gautam, Ashma, Shabir, Arsalan, Abdul. Nobody has solved it. Very easy question. Okay, see, you have to select members for a committee which has 5 members, right? The first part says 3 men and 2 women out of 6 men and 5 women. So out of 6 men and this out of 5 women, you have to choose 3 men out of 6, 6C 3, 2 men out of 5, 5C2, right? And they both need to be chosen, right, for the committee to be formed. So we will multiply. In the second part also, 2 men, so 6C2 into 3 women, 5C3. All right. Okay, this is solving this. 6, 5 into 4 upon 3, 2 into 1 into 5 into 4 upon 2. 6 is cancelled. This 2, 20, 200. Gautam, the first answer is 200, not 100. Sorry, 120, not 120. This is 200. All right, 6C3 into 5C2.
Sir, how is it 200? It should be 3 factorial into 3 factorial, the denominator.
1 3 factorial is cancelled, right? From
Yes, sir.
yeah, 100. All right.
Yes, sir.
15, 150. All right. See, the easy way to calculate the C and everything is, if you have 6C2, you may use it or may not use it, like same thing. All right, it's your choice, not compulsory. If you have 6C2, write it as 6 into 5, right? 2 terms, because 2 is written here. 6C2, 6 into 5 upon 2 factorial, because 2 was here. Just a little trick. All right, it doesn't save a lot of time, but it saves a few seconds. If you had 5C3, then 5 into 4 into 3 upon 3 factorial. All right, you can use this or not use this, your choice.
Okay, sir.
Yeah, you can use the formula also. It just saves one step, nothing much. Gautam, how are you getting 12,000? No, 6C3 is not 120. This is just 20. All right, Gautam. And that is not 100, that is 10. So 120 into 10 is, sorry, 12 into 10, not 12. How are you getting 120, Gautam? Is your mic working?
Sir, first one I got 3 men and 2 women I got 200, and 2 men and 3 women I got 600.
TEN.
Sorry, how can you come again?
3 men and
Why?
2 women I got 200,
Why?
and 2 men
All
and
right.
3 women I got 600.
How did you get 600?
Like this. Pen should not come like this.
So 6 C2 into 5 C3.
Okay, then multiply it again. All right. It is not 600, it is 150. All right. So I hope this question is clear, everyone. Moving on. Write down. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? In how many ways? First part is 4 cards are of the same suit. Four cards belong to 4 different suits. Four cards are face cards. Two are red cards. And 2 are black cards. Cards are of the same color. All right. Write it. Everyone here knows about cards, right? Anyone here who doesn't know about cards, color, suits, like how many cards are there and about the suits or anything like that? Okay, so everyone knows about it. Then try to solve this question. Okay, Gautam, I just asked you about this, right? If you know about suits or not. See, let me explain to all of you. Uh, a pack of card has 52 cards, all right, excluding Joker. 52 cards, and it has 4 suits, all right, diamonds, clubs, hearts, and spades, all right. These are suits. Diamond looks like this, clubs is this one, hearts and spades, all right. So 52 cards, so all have 13 cards in themselves. Every suit has 13 cards. A, then 2, 3, 4, 5, 6, 7, like this, 10, then J, K, and Q. Each suit has these numbers, right? There is no 1 but A, all right. This is called face cards, all right. J, K, Q is face cards. J, Q, and K. J, Q, K, face cards. So Gautam, how many face cards are there in a pack? No. See, this suit has 3, then this suit 3, this 3, this 3. So in total, we have 12 face cards. Yes, right. And see, diamonds and hearts are of red color. This is red, this is red, and this is black, and this is black. All right. So cards are divided in 2 colors, black and red, and 4 suits: diamond, clubs, hearts, and spades. Uh, 3 face cards to each of the suit, so 12 face cards in total. 4 aces, right, of each color, 1. Rest you can see. All right, now try to solve this. Shabya, you can send me all the answers. Okay, we'll discuss after a few minutes. Yes, Shabya. We need 4 cards, right? So each card comes from each suit, and we need to multiply them. No, they can be of any suits, right? They only need to be 4 face cards. No, no, Shabya, see, you in total we have 12 face cards. So you only need to select 4 out of 12. So 12C4. Yes. Okay, let's see. In the first part, it says 4 cards are of the same color, same suit, right? So 13C4, right? Each suit has 13 cards. You can select 4. So either this or this or this or this one, right? So this is the answer in the first part. For the second part, 4 cards belong to 4 different suits. So we need each card from each suit. So 1 card from each suit. So 13C1 and 13C1 and 13C1 and 13C1. This is second part. In the third part, 4 cards are face cards. So in total we have 12 face cards. You need 4, so 12C4. In the fourth part, 2 are red cards and 2 are black cards. So total red cards 26. You need 2, 26C2 into 26.
26.
Yeah, 26C2. Why we multiplied? Shavya, is it clear?
Yes, sir.
All right.
And black cards.
Yeah. Cards are of the same color. Fifth part, same color. That means it can either be black or red. So if you have to choose black cards, then 26C4. So this or red. So
Plus.
or means plus, or 26C4. This is the answer. All right. You can solve this, simplify, and get the answer. Clear, everyone? Gautam, Ashma, Arsalan, Abdul.
Yes, sir, clear.
All right. Okay, next question. In how many ways can a cricket team of 11 players be chosen out of a batch of 15 players if there is no restriction on the selection? A particular player is always chosen. A particular player is never chosen.
So what is that after 11 players be?
Be chosen
Okay, sir.
out of a batch of 15 players if there is no restriction on the selection. A particular player is always chosen. A particular player is never been chosen. Try to solve this. All right. Anyone solve this? Gautam, Ashma, have you solved this?
Sir, I've sent the first answer.
Yeah, you send the first answer. And the second part?
Doing so.
All right. No, particular player is chosen means one player is already selected, right? One of the 15 is there in the team. See, let me solve this. The first part is very easy. You have to select 11 members out of 15. So 15 C 11. In the second part, a particular player is always chosen, right? So out of 11, we have already selected one member, right? The remaining 10 we have to select from.
C10.
Absolutely right. 15 C 10. Not 15, in fact 14 C 10.
Yes, sir.
Right? 14 players are left. So in the third part, Shabba, can you answer the third part?
Sir, no player is like all the players are there. So is it 15 C11?
Not 15. Again, see, one player is never chosen. That means out of
Yes,
14,
14
right?
C10.
11. No, you have to choose 11 member team, right?
Oh, okay, sir. Understood.
Right? Yeah. So 14 C 11. I hope everyone this is clear.
Yes, sir.
All right. Next question. A committee all right, Gautam, you can match the answers. All right. A committee of 12 is to be formed from 9 women and 8 men. In how many ways this can be done if at least this question is wrong, I guess. If at least 5 women, right? If at least 5 women have to be included in the committee. All right. A committee of 12 is to be formed from 9 women and 8 men. In how many ways this can be done if at least 5 women have to be included in the committee? Try to solve this. See here, for a hint, you can think, if I tell you you have at least 10 rupees, that means you can either have 10 rupees, 12 rupees, 15
10
rupees,
or
right?
more.
Yeah. So you have to make cases here. 5 women, 6 women, like this. All right. Then solve each case individually. All right.
So till 12 women.
Yeah,
Till
but
9.
9 women, right? Because the maximum can be 9. Shavya, if you choose 5 women out of 9, then you have to also choose 7 men from 8 men, right?
Yes, sir.
Yeah. So think about the whole team. All right. Let's see. You need to choose 12 members for the committee, right? Out of 9 women and 8 men. At least 5 women has to be chosen. First case, 5 women and 7 men. So 5 women from 9, 9C5 and 8C7, right? You have to choose 7 men from 8 men. Second case, 6 women and 6 men.
So
So
why are we considering 7 men?
because in total we have to choose 12 members, right?
Understood, sir.
Yeah. 6 women, 6 men. So 9C6 into 8C6. In the third case, we can take 7 women and 5 men. So 9C7 into 8C5. Fourth case, 8 women, 4 men. 9C8 into 8C4. In the fifth and last case, 9 women and 3 men. And this is 9C9 into 8C3. So this is the answer to all the parts. Clear, everyone?
Yes, sir.
All right. Gautam, Ashma, Arsalan, Abdul. Once more. All right. See, Gautam, if I ask you, I bring samosas and I tell you you have to eat at least 3, right? That means the minimum is 3. You can eat 4, 5, 6, 7, as much as you can. So here the question says you have to choose 12-member team, right? 12-member committee. But we have to have at least 5 women, right? There cannot be less than 5 women in the team. So what are the cases that I can make? I can take 5 women, 6 women, 7 women, 8 women, or 9 women, because in the maximum we have 9 women, right? So if I have to choose 5 women, then the remaining has to be men. So 7 men. But if I choose 6 women, then 6 men has to be chosen. If I choose 7 women, then 5 men has to be chosen. Like this, all the cases. The final answer would be adding all of them, right? Because either this case or this or this, right? This or this or this or this or this. You have to add all of them. And how to choose this? 5 women out of 9 women. So 9C5. And you have to choose 7 men also. So 8C7 in multiplication. And so on for everyone. Is it clear, Gautam?
Yes, sir.
All right. Next question. If there are 12 persons in a party and each of them shake hands with each other, how many handshakes happen in the party? All right. This is a bit new type question. All right. You can solve if you want. I'll give you 2 minutes. Otherwise, I'll discuss. All right. There are 12 persons in a party. Each of them shake hands with each other. How many handshakes happen in the party? So anyone, any ideas? 12C11. Why 11, Shafia?
So one person will shake hand with the rest of the persons.
But everyone will shake hands with each other, right?
Yes, sir.
So think you thought like your thought was in the right direction, all right? You just needed to think a little bit more. See, for each handshake, we need two persons, right? As soon as two persons meet, we have one handshake, right? So
Yes.
out of 12 persons, the number of pairs we can choose will be the number of handshakes that are happening. Is it clear, everyone?
Okay, sir.
So the number of pairs we can choose is 12C2, and each pair will have one handshake. So total number of handshakes will be 12C2. Clear?
Okay, sir.
Okay, this was very easy question, but if you don't know this, then it becomes very tough to solve. Next question. Write it down. Another question. In how many ways can a team of 4 boys and 4 girls be selected out of 6 boys and 5 girls if a particular boy and a particular girl refuse to work together? Try to solve this. In this question also, you have to make cases, right? Suppose we have B1, B2, B3, B4, B5, B6, G1, G2, G3, G4, and G5, right? We have 6 boys and 5 girls. Suppose B1 and G1 don't want to work together, right? A particular boy and a particular girl refuse to work together. They will never work together. So make cases in this, like first case, second case, and third case. In the first case, take as B1 is working, all right? Because see, three scenarios are possible. Either B1 is working in the team, or G1 is working in the team, or neither of them are working, right? No scenario except this is possible. So take the first scenario as B1 is working in the team or selected in the team. In the second case, take G1 is selected in the team. In the third case, neither B1 nor G1 is selected. All right, then try to solve this. Is it clear, everyone? Or is it like sounding difficult?
Sir, can you explain once more?
Yeah. See, Gautam, the question says you have to make a team of 4 boys and 4 girls, right? But one particular boy and a girl don't want to work together. So in the team, like you have to select a team, right? So suppose you selected 8 boys, 8 member team. So what can be the scenarios that are possible here? In the 8 member teams, either B1 is there, right? Because if B1 is there, G1 cannot be there, right, Gautam?
Yes, sir.
So either B1 is there or G1 is there in the 8 member teams. Because if B1 is there, then G1 is not there. If G1 is there, then B1 is not there. Or there is a third scenario where they both are not present, right?
Yes, sir.
So these are the 3 cases that we need to make. In the first case, B1 is compulsory. You have to choose B1, right? So out of 8 members, B1 is one of them. So you have to choose 7 members out of the rest. In the second case, make G1 compulsory. In the third case, neither B1 nor G1 goes. You have to choose the team out of rest of the students. Is it clear now?
Yes, sir.
Okay, try to solve this. I'll give you 2-3 minutes. Shavya, Ashma, clear?
Yes, sir.
Okay.
Yes, sir, clear.
Okay, so how to solve this? In the first case, I'm assuming B1 is there, but G1 is not there. All right, B1 is there, but G1 is not there. So out of how many boys we have? 6 boys, right? So when B1 is already there, so you have to choose 3 boys out of 6 boys. So 6C, 3, and G1 cannot be there, right? So you have to choose 4 girls out of 4 girls. So 4C, 4. In the second case, B1 is not there and G1 is there. So 6C4, or sorry, 5C4, because B1 cannot be there. So you have to choose 4 boys out of 5 boys, and G1 is already there. You have to choose 4 girls out of 4 girls. And this is also 5C3 because B1 is already there. All right. In the third part, neither B1 nor G1 is there. So you have to choose 5C4 into 4C4. All right. Is it clear, everyone? Okay. 5C4. Oh, so this is 4C3. You have to choose 3 girls. Clear? Shravya, Gautam, Ashma?
Yes, sir.
All right.
So how is it 5C3? Like why you pick 5?
Here in the first part,
Yes, sir.
see, because we already said B1 is already there. Okay, B1 is compulsorily there. So we had to choose 4 boys out of 6 boys, but we already sent B1. So you have to choose 3 boys out of 5 boys. Remember that question, the cricket team question, I think, right? One particular boy has to be chosen, one particular boy is never chosen. It's like that question. B1 is already selected. So you have to choose 3 boys out of 5 boys. Is it clear now, Gautam?
Yes, sir.
All right. Next question. A box contains 2 white balls, 3 black balls, and 4 red balls. In how many ways can 3 balls be drawn from the box? If at least one black ball is to be included in the draw.
Sir, one doubt I have from previous question.
Sorry.
One doubt I have from previous question.
Yes, ask please.
Yes, sir, how we are taking four for girls?
In the first part.
Second part.
Second part. See here, this is similar to first part. In this, we said B1 cannot go there, but G1 we have already chosen, right? So because G1 is already there, so we have to choose 3 girls, and in total we had 5 girls, but G1 is already there, so we have to choose out of 4, right? Only 3 girls, so 4C 3.
Sir, what about third one? 4C4.
Yeah, in the fourth one, neither B1 nor G1 can go, right? So you have to choose 4 members out of 4 girls and 5 boys, because we excluded B1 and G1. Is it clear, Gautam? Shall I explain again?
No, sir, it's clear.
All right. Try this question then. Here also make cases. At least one black ball means either 1, 2, or 3, and try to solve these cases. I'll give you a few minutes.
Sir, is it if at least one black ball is to be included in the draw?
Yes, at least one black ball is to be included.
Okay, sir.
All right, Shabya, no worries. Or you can just listen to this solution. All right. This is the last question of today's class.
Yes, sir.
Okay. So in the first case, let's say we have exactly one black ball. All right. So we had to choose three three balls. One is black. So 3C, one out of three black balls, we can choose one into. Now out of six balls, two white and four red, we have to choose two balls. So 6C2. In the second case, let's say we have exactly two black balls. So 3C2, two black balls out of three black balls into, we have to choose one ball from six balls, two white and four red. In the third case, we can take exactly three black balls. So 3C3, right? You can simplify this, add them, and that will be the answer, right? We'll add them because either this or this or this. So we will be adding the solution. This is method 1. In method 2, you can do one thing. You choose total 3 balls out of 9 balls and subtract where no black ball is chosen. All right, all the cases where no black ball is chosen. If you cancel that, from this you will have the answer. So 9C3, no black ball, that means you have to choose 3 balls out of 6. 6C3. Why 6? Because 2 white and 4 red. You cannot choose any black ball. So subtract that from this. This is the same answer. All right. You can try both the methods. We'll have the same answer. Is it clear, everyone?
Yes, sir.
All right then. So this is about selection. You complete the assignment and NCERT permutations. All right. See you in the next class. Take care.
Thank you, sir.
Yeah.
Thank you, sir.